I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College. So friends, in this series of data mining course, we are learning a lot of concepts about the domain of data mining. And in the last few lectures, we are talking about how the actual mining exercise is carried out, or what are the different processes which can be used. So we were talking about classification analysis for mining of data, and we had seen that basically in the classification analysis we try to divide the data, or we try to sort of categorize the data into predefined classes, and we assign a label to them. Right. So we had seen a few examples, and now this lecture will be taking forward from the basic introduction, and we will be talking about how the attribute selection is done, how the model classification model is formed, and how this model can be evaluated, that whether the model is the correct classification model or we need to do it. And also it is very important at this stage that we understand how the classification algorithm will work, how it is designed, and how the different conditions of the classification algorithm need to be specified in this. So friends, let us quickly look at the different types of learning systems that we see. For example, we know that there are two types of learnings. First is the supervised learning, and the second is the unsupervised learning. So when we talk about classification systems, it is basically the supervised learning model that we are looking at. And when we are talking about supervision, what is supervision? That we are giving a training data set, okay, and with the training data set we are giving some predefined labels to the data. So every class of the observation will be identified by a data label that we are giving. So the training data, it could be observations, it could be measurements, whatever, it is always accompanied by a label which will tell us that what is the class of that observation. And new data, whatever new data is going to come, that will be classified based on the training set that has been provided. So basically classification will come under supervised learning. If you talk about unsupervised learning, which we also call as known as clustering, in clustering what happens, that there are no labels which are put, there are no class labels which are identifiable, and we have a set of measurements or we have a set of observations, and all these are with the aim of establishing the existence of classes or clusters in the data. So unlike classification, in clustering there is no class label which is available, and whenever we get a data set, we have to identify the class and we have to put it in the relevant cluster. So when you talk about classification, so there are two things which we commonly talk about. One is the prediction problem, that is when we are talking about predicting the class of an observation, or we are talking about numeric prediction, right. So when you are talking about classification, what are we predicting? Actually we are predicting the categorical class label. So generally prediction problems, or the problems which are solved through classifications, are the ones which have discrete or nominal attributes, right. So they are going to predict the class, right. So basically what we are doing is we are constructing a model which is using the training set, and there are some values which are called the class labels, and these class labels are based on a particular attribute which is known as the classifying attribute. And using this model and the training which the model has been given, and the attribute which is identifying the class, we will use to classify any new model. So we are going to predict the class of the of any new observation when you look at the model and you look at the attribute of the new observation. Whereas if you talk about numeric prediction, Right. Now in numeric prediction what happens, it is basically generally used for continuous valued functions, right. That is whenever you are having some unknown values or you are having some missing values, right. If you remember, we had talked about in data pre-processing also, we had talked about predicting the values for numeric data and using various mathematical functions to find out the values. Right. So that kind of a problem is like when your data is having continuous values or it is nominal values, then you will go for numeric prediction. But if your value is a discrete data, then you will go for a classification kind of prediction solution. So there are many applications where we will use the classification method or classification process, like credit card loan approval, or in case of diagnosis to know whether a particular tumor is cancerous or it's benign, or in case of credit card fraud detection to know whether a transaction which is happening through a card is a fraudulent transaction or not, or to categorize the web page into different categories. So likewise there are n number of applications for this class for which classification problems can be used. So actually if you look at classification, so classification is a two-step process. Two-step, why? The first step means that you are constructing a model. We just saw that first thing is that you have to build a model which will describe the set of predefined or predetermined classes, right. So any tuple or any observation which is coming, it is assumed to belong to a predefined class, okay. And how is that defined? The class is predefined by the class label attribute. So the set of tuples which are used for model construction, those set of tuples are known as a training set. So basically you are using a set of tuples which you have already classified, you have already assigned a class label to those tuples, right. So that data set is a training data set. Using this training data set, you will make the system learn, you will construct the model, and this model is represented as classification rules. The model can be represented in the form of decision tree or it can be represented in the form of mathematical model. But the basic crux of building or constructing the model is this. The second step in the classification is to use the model. So now we have we have constructed a model. Now we are going to use this model for classifying any future unknown objects, right. So whenever you build a model and you are using a model, you need to do an estimate of the accuracy of the model. That is very important, because if your model is not giving accurate results, then it is of no use. So now second thing is the accuracy evaluation, or the evaluation of the model. So what you do is you have a known label of a test sample, because we've used certain tuples for test training. So we have those known labels, and then we also have the classified result from the model. So we will compare the known values with the model, with the results which are generated from the model, and the accuracy rate of the model will be the percentage of the test set samples that are correctly classified by the model. So higher the accuracy, of course better and more acceptable the model. So this error, actually we will be talking about this later when we talk about evaluation of the model. So we need to find out the error in the data, error in the results of the test set samples and those of the results which are obtained by the model. So after you have constructed the model and you calculate the accuracy or you evaluate the performance of the model, only then, when you are certain about the results, only then you actually run the data, run your unknown objects on that particular model, right. So the test set, whatever is being used, it is independent of the training set, right. So if the accuracy is acceptable, then we are going to use the model. And there is also one more term which is used, which is known as validation set, or validation test set. That is, if the test set is used to select the model, right, looking at the results which are obtained from the test set, you decide whether the model is to be used or not. That is known as the validation test set. Okay. So if you look at this diagram, it very clearly shows the first step, that is how the model is constructed. So we have a training data set. Okay, the table has been given here, that is our training data set. Now using this training data set, a classification algorithm is used, right, and the model or the classifier model is built, right, and accordingly the tenured class is the label of one attribute is assigned. So what is the classification model doing here? It is comparing the rank of the tuple and it is comparing the years. So if rank is professor and years are greater than 6, then it is put under the class tenured is equal to yes. So this is how we use a particular data set, training data set, to train the model. After the model has been built, after the model has been constructed and this particular rule has been clearly understood by the model, then we use this model for predicting. So now we have some test data with us. So this test data is then used for the classifier, it is put in the classifier model, okay, and you have some unseen or unknown data also, and using the testing data and the trained data, now we are going to put whether a particular attribute or whether a particular tuple, say here we know that Jeff is a professor and has 4 years of experience. So we now want to know whether he is tenured or not. So the model will give an answer. Now depending upon the result what the model is predicting for the class, we will evaluate whether the model is an accurate model or it is not an accurate model, whether it can be validated or it cannot be validated. Okay. So basically when we are looking at the classification data or the classification attributes, so we have seen earlier that there are multiple types of attributes. We know that there are some attributes which are categorical attribute, where you have binary values like whether you are a homeowner, yes or no, right, or whether the marital status is single or it is married, or you can also have a third three-way categorical attribute or a multi-value categorical attribute like single, married and divorced, like that. And then there can be other attributes which are like continuous attributes. So if we are looking at taxable income, now that is a continuous attribute, and now we need to use these different attributes for building a classification model, for actually classifying the data set into different class labels, right. So out of this data, now this data, the idea here is that different types of attributes can be used for building the classification model here. So we have a certain test data. Using this test data, we are building the model, and then from the model, using the model, we are making it learn. Okay, the model is used for training, using the training set it is learning, and then this model is finally giving the results for the test data, right. So this is how the entire process of model construction and model usage is being implemented, right. So if you look at the black box approach of the classification model, it is simple, that we have an attribute set X which is the input. Okay, this attribute set X, when given into the classification model, will provide you with a class label, say Y, right. So one attribute is classified or is given a class label once it is put into the classification model or the classification algorithm, right. Now we had seen that there can be multiple approaches which can be used for classification systems, like we had seen there can be numerical classifiers, or the very popular and very commonly used classifier is the decision tree classifier, right. Now decision tree classifier is a very simple approach, and we had discussed about this earlier also, that in this we have an edge, okay, and you have certain terminal nodes and you have a non-terminal node. So non-terminal nodes means that they are further going to break out or split into child nodes, whereas the terminal node, that is the leaf node also we call it. So that node is the final node. So there is no further node which is going to follow a leaf node. That is, we have assigned a class label when we reach the leaf node, right. So it is one of the simplest classification techniques which can be used, right. So if you look at this table, in which we are trying to distinguish between mammals and non-mammals. So we have certain attributes which are given to us, okay, and these attributes will be used. Out of these attributes, certain attributes will be used for classifying a particular organism as being a mammal or as being a non-mammal. So if we look at how the decision tree is being built, so we have this mammal classification. So in this, the first node or the root node, what we call it, is the body temperature. So this is the first attribute on which we are trying to check. Now body temperature can have two values. According to our data set, body temperature is having only two values, either it is warm or it is cold. So we can see that depending on whether it is warm or it is cold, we have two further internal nodes. So after we know that the body temperature is cold, we come to a leaf node, that it is a non-mammal, knowing that mammals are warm blooded. Okay, so the one side of the tree ends here itself. But if the answer is a warm blooded, then we need to further recursively again check for another attribute. So we can see in this data set there is another attribute, that whether it gives birth or it does not give birth. So then again this is a binary value, because it will say either yes or no. So then it is going to give the classifier as, if it is yes, it will be a leaf node saying mammals. If it is no, then the leaf node will say non-mammal. So we are going to stop at the point where the leaf nodes are having similar values, that is, no further question can be asked. So right from the root node, this is actually a recursive approach which will be used to build the decision tree classifier. Another example, if we see, of the decision tree approach is the homeowner problem, which was discussed earlier also. And here also what we are doing is, we are seeing that there are different types of categorical and continuous attributes which are there, and accordingly we are going to identify and give a class to it. And basically what we are doing is, we are trying to split the node depending upon the outcome of the previous node, right. So this is also similar example on which we are going to use it, right. So this is the attribute test condition, where you have a binary attribute, where the attribute has got only two values, either warm or cold. So this kind of attribute condition can be used for that purpose. Now when we are looking at the decision tree induction, that is, we need to define and we need to develop an algorithm based on this approach of the decision tree, right. So the very popular algorithm which is used for the purpose of designing decision trees is known as the Hunt's algorithm, right. So it is a generic procedure. The Hunt's algorithm is a generic procedure which is used for growing decision trees in a greedy fashion. Okay. So greedy fashion means that we do not want to expand the tree to a very large extent. A tree which is very long or very large will be very complicated, and it will further lead to some quality issues, right, like model overfitting. So we really want to build the tree in a greedy fashion, so that the tree grows to a minimum extent. So to implement the algorithm, there are two main issues that need to be addressed. In any problem, if you are using the Hunt's algorithm to solve the problem using decision tree classifier approach, then you need to understand that what is the splitting criteria, what is the basis on which the splitting is being done. So we have seen in the previous example also that at each recursive step we need to identify, we need to pick up an attribute. Like in the vertebrate, in the mammal example, first we took out the attribute which said whether it is warm blooded or cold blooded. After that we selected another attribute from the data set itself, that is whether it gives birth or it does not give birth. So what are we doing? We are actually taking a recursive approach, and in each attribute selection we are going back and we are picking up an attribute to identify more attribute values and to identify or find out more class labels, right. So what we are doing is that we need to select the attribute, okay, and then using this attribute that we have selected, we will partition the training instance associated with the node into smaller subsets associated with its child nodes, right. So we use give birth. Now what are the child nodes which will come? Yes or no, right. So the splitting criteria that we are using will determine which attribute is chosen as the test condition. This is very important, that when you want to, when you want to split the node into child nodes, you have to see that what is the test condition and how the training instances should be distributed to the child nodes, right. Because as I just said, that we do not want the child nodes to be very high in number. So we need to see that the training instances are apportioned or divided in the child nodes, keeping in mind that the tree does not grow too much in size. Second criteria which we need to understand, very important, is the stopping criteria, right. So you are going on splitting the nodes, but you need to see that we have to stop this algorithm, we have to stop the nodes from expanding only when all the training instances associated with the node have the same class labels, right. So whatever you are giving, if the class labels are coming the same, then you need to stop it, you don't have to go any further down, right. So these conditions, both these conditions, that is what is the splitting criteria and what is the stopping criteria, both these conditions are sufficient, and there are reasons to stop expanding a node much earlier, even if the leaf node contains training instances from more than one class, right. So the entire process of terminating your the splitting option early or the splitting criteria early is also known as early termination, okay. And the condition which is used to determine that when a node should be stopped from expanding is called as the stopping criteria, right. So in order to get an early termination, we need to see that the node is fulfilling the stopping criteria. The node has to fulfill the stopping criteria, then only you will take it for early termination, right. Now there are different methods, because we are talking about how to select the particular attribute and how to define the test condition for that particular attribute. So there are multiple methods which are used for expressing the attribute test conditions, right. Now decision tree induction algorithms, they will provide a method for expressing an attribute test condition and its corresponding outcome for different attribute types. So we had seen that there are different types of attributes in a data set. You can have a binary attribute, you can have a continuous attribute, right. You can have different types of attribute. So depending upon what is your attribute, what is the type of the attribute, you have to express the test condition, okay. And according to the test condition, you will have different types of outcomes. For example, if your attribute is a binary attribute, just like we saw whether it is warm blooded or cold blooded, so it has got only two values, so that test condition for a binary attribute will generate only two outcomes, okay. So there will be only two edges which will come out from the node of a binary attribute. If your attribute is a nominal attribute, so nominal attribute, we know that nominal attributes can have many values, right. So its attribute test condition has to be expressed in two ways. What are the two ways? Either it has to be a multi-way split or it has to be a binary split. Like for example, it can have n number of values. For example, we see marital status, right. Now marital status can have single, or it can be married, or it can be divorced, or it can be widowed. So there are multiple values, so there can be multi-way split, or we can also try to look at a binary split. So for a multi-way split, the number of outcomes will depend on the number of distinct values for the corresponding attribute, right. So if you have 4 distinct values which the attribute can take, so there will be 4 different outcomes. Okay, so for example, if an attribute, just now I explained that it can have different values, so accordingly the split will also be multi-way split. There is also an option to create a binary split for a multi-valued attribute also. So we will be looking at how we can look at a binary split by partitioning the different values taken by a nominal attribute. We will be seeing this in the following lecture. Till then, please keep watching CEC. Thank you.